all. I am Karthik from Sess Paper and Boards. I am here to discuss about energy consumption benchmarking in pulp and paper sector. I have come up with this work along with under the guidance of our Director of Operations, Mr. Ganesh Pati sir. Here are some infographics about our SPV. We belong to a Ashwin group and we are working in the field of paper, sugar, batteries and a consultancy firm. We help farmers to 16.4 crores of seedlings every year, and all our products are 100% recyclable and biodegradable. This presentation is structured as follows. I am here to cover energy and production scenario and net zero emissions, both global and national, and in particular pulp and paper sector. Also, I am going to discuss about the energy benchmarking in global and as well as national, and some interesting case studies where our SPV is moving into, and some future projects marching towards net zero emissions. First, about this energy and production scenario, global as well as in national. First, I talk about the global scenario. This primary energy use in 2021 was about 1.3%. It has got raised. So every time this primary energy use is increasing due to population and production rate, this economic growth at all. But this fossil fuel was reducing in a slow manner at around some 82% of primary energy use from fossil fuels. Earlier it was about 83 and 85. At the same time, this renewable energy has also got increased over 8 exajoules between these 3 years. And anyhow, this carbon dioxide emissions from this energy use rise up to 39 gigatons CO2 equivalent in 2021 from 34 tons. Why? It is because a small drop in 2020 due to this COVID situation, this mainly due to the transportation, this CO2 has come down. This is the global energy scenario. Here, anyhow, the total energy use will be in the increasing trend, but we were increasing the renewables. We were reducing the fossil fuel consumption. This is the primary energy demand in present and up to 2050. The second graph, it clearly explains the energy demand will be met mostly by the renewables. Around 106% there will be a rise. So this oil and coal, here this oil is around minus 10% and coal minus 20%. It is going to decline. In order to make up that, this renewable is going to raise about 106%. This is our projected world energy consumption scenario by fuel as well as in sector. The first graph, it clearly indicates that the usage of coal will definitely come down, whereas this renewable energy is getting increased. Then coming to the production scenario. In post-pandemic, the industries resume at a faster rate. This global manufacturing production is at a growth rate of 4.2% in the first quarter of 2022. Which means this is demonstrating a decoupling of growth in energy with production. Earlier I have told that this primary energy use has raised around 1.5%, whereas this production raises up to 4%. This demonstrates a decoupling of energy use with production. So not directly relating the higher the energy use and higher the production. We are increasing the production, but the energy use is little bit lower. This is a data from BP.com. This world reserves of fossil fuels. From from the latest statistics, coal and oil will last about some coal for about 140 years and oil for about 40 years. Then coming to our national energy scenario. Again, this we were at a strong growth in primary energy by renewables. Share of renewables in primary energy will increase from 31. Presently, we were at the 31%, but by the end of 2050, we will reach around 66%. This is what predicted. Mostly by electrification, we can achieve more in the field of the renewable energy. From 55%, it can be raised up to 95% by 2050. Also in support, our government of India has a target of installing 175 gigawatt of renewable energy capacity by the year 2022. Then comes to our national production scenario. Almost Indian industries are also showing an accelerated growth post-pandemic. Manufacturing and production in India averaged up to 5.89% from 2006 to until 2022. Anyhow, there is a small drop in production during the COVID-19, but post-pandemic it has increased up to 5.89%. Also, some initiatives by our government, like Make in India, are aiming to turn our South Asian country into a global manufacturing hub. So, the production rate is also going to increase. Then coming in particular to our pulp and paper sector, the energy and production scenario. First, this primary energy use in pulp and paper was around 0.1% in between 2010 to 2019. But the output from our pulp and paper industry is increased 0.3% per year. So this also demonstrates that the decoupling of energy, the decoupling of growth in energy consumption from growth in production. Anyhow, we were meeting our production demand. The two major challenges we were facing is, one is environment, to take care of the environment, and energy. These are the two principal challenges for sustainable development. Managing the natural resources without any depletion and negative impact. This is make it this natural resources we will make it available for our future generation. This is our energy scenario in pulp and paper industry. Looking at the last column, this MTOE per ton of production will come down up to 1.36 by the year 2030. Presently, we were at 1.51 TOE per production. Also, this energy scenario, most pulp and paper industry are focusing on using of this biomass materials, and for paper making, we were going for recycling paper. Also, this recycling paper also will bring down our energy use compared to using virgin raw materials. This is our production scenario in pulp and paper industry. The first graph shows again this oil and as well as this coal consumption will comes down. This bioenergy will goes up. This bioenergy around 22%, it will go up. Similarly, the production scenario, it will reach, it will increase up to 16% from now, up to 2030. This net zero emission, it is also as important as the energy and production scenario, and presently it is more important to know about the energy net zero emissions. Here I have covered the global and national level of this net zero race. About the net zero emissions, it is achieving a balance between the GHG emitted as well as taken out from our atmosphere. This we usually describe as carbon neutrality, we can achieve this net zero emission by some 4 ways, like generating the electricity without any emissions, and using of vehicles and equipment that are powered by electricity without any fossil fuels, and using energy more efficiently and reducing the carbon dioxide from atmosphere. This is our projected net zero emissions by 2050. It is taken from iea.org. Number of steps have been taken to achieve net zero. Initially, when we look at this 2020, there will not be any new sales of fossil fuel boilers, no new oil and gas fields approved for development, and no new coal mines extension. We have already stopped all these things. So this will lead slowly to achieve net zero. By 2030, the low emission technologies in heavy industries will come. The electric car sales and solar and wind energy, the production of solar energy and wind energy, and some even electric motors, we will be using the energy efficient one. All these things will lead to net zero. Net zero emissions in pulp and paper sector. This net zero emissions by 2050 scenario, this energy use increases 0.5% per year to 2030, while the annual paper production expands 1.5%. Greater the recycling, lower is the energy consumption. By producing paper from this recycled sources, will help in reduce the energy intensity. Using a higher share of bioenergy and adopting waste heat recovery technologies, we can achieve net zero. Also, some paper industry projections by 2030, this paper production increase up to 37%, and this definitely there will be a reduction in the fossil fuel. So thereby the CO2 emissions will also reduce up to 31%. With the increased use of renewable energy, about 25%. So in highlights, our anyhow this primary energy use will be in the increasing trend, whereas our production will also in increasing trend, but there is a decoupling from growth and production. Coming to the energy benchmarking, global and national. This benchmarking is a competitive tool for comparing with our competing industries, and it is helpful to perform a gap analysis between their value and our value, and where we can implement any energy efficient ideas, or it will provide directions for opportunities, energy opportunities like that. So this energy is a cost competitive as well as it is a controlled variable in our in any industry. So by reducing the energy, we can produce the products at a lower rate. So this is our overall energy consumption, that is specific energy consumption. Our national benchmark is about 0.607 MTOE per ton of finished production, but in our SPB in 2021-22 it was 0.402. So we were at 23% reduction from the last 3 year data. Then coming to the specific power consumption trend, our national benchmark is about 1500 units per ton of production, whereas the global benchmark is 1100 units per ton of production. But in our SPB 2021-22, comparing this the last 3 years, the reduction is about 11%, and in last year we were around 1411 units per ton of production. Then coming to the steam consumption trend, our national benchmark is 9 tons per ton of production, and in the global it is 13 tons per ton of production, but ours is 7.38, but compared to the three years data, it is about 10% reduction. Here to discuss some interesting case studies from SPB. Our manufacturing is focused on minimizing the environmental impact and global warming, elimination of waste, and maximizing the green resources in our business, sustainable development, and improvement in performance efficiency and profitability. Likewise, our approach towards energy benchmarking and net zero. These 4 themes we have taken in order to bring energy to emissions to net zero. First is energy efficiency and behavioral change, electrification and renewables. Also we have projects, worked some projects over these themes. The first is the energy efficiency. Energy efficiency, there are still opportunities for energy efficiency improvements and behavioral change, reducing the excess wasteful energy use, transport mode switching and material efficiency. This electrification, the acceleration of electricity demand from 2% over the past decade to 3% per year throughout 2050. This will increase the share of renewable electricity generation, and we were also working on it. And coming to the renewable energy, we from our pulp and paper sector, we have black liquor. It's one of the renewable energy that we can use in pulp and paper industry. So for focus on this net zero emissions, we have certain targets and the energy management systems by monitoring our projects, and we make this process and resource efficiency, and we are looking into our environmental performance and to the sustainability. The right side of the column, I have taken some 5 interesting case studies which work on the theme of energy efficiency and renewables. For energy efficiency in thermal part, we have 2 case studies. One is installation of black liquor, white liquor spiral heat exchanger in RTH. And the next one is installation of indirect heater for heavy black liquor in recovery boiler. The third one is process re-engineering in evaporation plant. And fourth one is modification of existing digester in wood pulp mill. And fifth one is biogas firing in lime plant. We will see one by one. The first case study is the installation of black liquor, white liquor spiral heat exchanger in RDH. Earlier, white liquor supplied from chemical recovery plant is about 60 to 70 degrees Celsius. They use shell and tube heat exchanger for heating up to 100 degrees Celsius only. But even then, the requirement is about 120 degrees Celsius. We go for a spiral heat exchanger. The spiral heat exchanger due to this continuous countercurrent flow, the heat transfer rate is high. So with the increase in the heat transfer, we can exchange the heat from black liquor and white liquor. Earlier, the black liquor supplied to chemical recovery plant is about 90 degrees Celsius, but after installation of the spiral heat exchanger, the black liquor supplied to our chemical recovery plant is about 82 to 83 degrees Celsius only. Again, this heat is being utilized by the white liquor. So, with white liquor supplied from chemical recovery and the black liquor needs to be supplied to chemical recovery, both the heat is exchanged using the spiral heat exchanger, which gives a 100% pure counter current flow resulted in this performance highlights. Earlier, the cyclical outlet temperature was about 100 degrees Celsius only. After installing this spiral heat exchanger, it came up to 120 degrees Celsius. Again, this WBL supplied to the chemical recovery complex is earlier was 90 degrees Celsius and presently at 82 degrees Celsius only. So, we may know about the 3 T's of combustion. One is temperature and time of mixing and turbulence. Now, this 3T is not only for combustion purpose also. In mill-wide, we can think over it and we can implement one by one on anything on these 3T. Here, in the spiral heat exchanger, the turbulence, this T we have attacked. Due to this continuous counter current flow and the high shear rate, the turbulence is created. Due to the higher the turbulence, higher the heat transfer coefficient, and this heat transfer, the heat exchange is good. So the WBL temperature we have reduced up to 82 degrees Celsius, which helps in recovery plant a lot. So these are the outcomes of this project. The steam savings we have achieved about 25 tons per day and cost saving about 46 lakhs. The next case study is installation of MP steam indirect heater for heavy black liquor. Earlier we have a LP indirect heater. It raised the black liquor temperature up to 135 degrees Celsius only. With that, we will increase the black liquor temperature up to 130 or 132 degrees Celsius by direct heating. This direct heating, we use MP steam, which means that we directly add steam to the, directly adding condensate to the black liquor. This can be avoided by means of indirect heating. So we have installed a new MP steam indirect heater for heavy black liquor. Earlier the heater gain was around 5 degrees Celsius only. After installing this MP steam indirect heater, we are getting about 10 to 12 degrees Celsius, so that we can able to raise the temperature of black liquor by around 130 degrees Celsius, maybe the rest 1 or 2 degrees Celsius by direct heating. So this will directly affect the flue gas volume. So this made the trigger up for this project. This heavy black liquor is heated in with the direct and indirect heat exchangers. Earlier it was an LP steam indirect heater. Presently we are installed a MP steam indirect heater. This will raise the temperature up to 130 degrees Celsius. This MP steam directly entering into the boiler can be avoided.
Can you finish within 5 minutes? 5 minutes now.
Also keeping in mind about our after the augmentation of recovery boiler about 950 tons per day, this MP steam indirect heater is helping a lot. Presently our HBL fire is 950 tons per day. This extra steam generation about 0.1 to 0.15 tons per ton, with about 95 tons per day extra steam we are producing. This gives the benchmarking in steam per ton of dry solids fire. Since we have some values from our competitors, our SPB is about 3.25 tons per ton of dry solids fire. Next, coming to the third project, this HBL generator is slowly increased in a phasal manner, phase 1, phase 2 and phase 3. The first phase shifting of ash crystallization and diversion of vapor from PCFT1 to the calendar year 3 vapor getter, and phase 2 running of second effect in parallel mode, and phase 3 is the digester modification. So with our in-house team and not going into the capex projects, we brainstorming ourselves and look into the project. Even our OEM supplier recommended to go for major investment, but we debottleneck our evaporator and we made to run to meet the demand of 850 to 850 tons per day. So in phase 1 we have first shifting of ash crystallization. Earlier we use the ESP ash into the second effect. Next we add the ESP ash into our first effect. This may earlier the tube jamming was about 800 to 900 tubes. But after shifting of this ash crystallization, the tube jamming itself has come down up to some 200 tubes, and the tube cleaning frequency earlier once in 30 days we used to clean the tubes. But after this project, it was increased up to 2 months. And every day we used to wash the calandria 3. That time this vapor from PCFT1 was left unutilized. This was given to the vapor header. During that time, not using for calandria 3 also, it can be used for the calandria 4. So that time the feed restrictions was avoided and can able to meet the demand for HBL firing. Again, the running of gas, like first effects, running second effect also in parallel mode, that is liquor in series, whereas this vapor in parallel for the second effects. After introducing some valves to give vapor in parallel to the second effect, we will meet the demand of about 860 tons per day, and also we are able to fire 900 tons per day of solids firing without any capital expenditure. That is, before augmentation also we were able to fire about 900 tons per day. See, this is the after the phase 1 with the diversion of vapor as well as the shifting of ash crystallization, we can able to run about 215 m3 per hour of WBL, and after the phase 2 we were able to run 250 m3 per hour of WBL. Once this debottlenecking in evaporator was completed, then we entered into digester modification. This digester modification, we have modified this digester in 3 parts. One is, earlier we have air evaporation at the bottom of the digester. We have introduced one more line from the top and connected to the same air fan, so that the evaporation, once the chips fill up most, the excess air we will remove through the air fan from the top also. So this reduces the chip fill time by 7 minutes, and also the chip fill quantity of the digester also increased by 1.5 tons. So in the second picture, we have introduced one more valve and a line to the same existing fan. This improves the air evacuation in one digester. Only we have implemented in only one digester, that is working good. And in the middle portion, the liquor header circulation, earlier it was about 12-inch dia, then we replaced into 16. That pump has the capacity to have a more circulation rate, so we increased the dia up to 16-inch. So this also the circulation volume has increased, and this TTT cycle time has reduced by 15 minutes per cycle. Mostly in digester, we attack the 3T concept. Here it is time. And finally, in the pump out stage, the enlargement of the discharge line nozzle from 300 mm dia to 500 mm. This will increasing the pump out in one stroke. The cycle time reduction from overall doing all these things, this cycle time reduction from 310 minutes has reduced up to 280-290 minutes per pump out. This is a major modification we have done in our digester, which helps a lot in firing 950 tons per day, and also the increased pulp production is about some 80 tons per day of 50 tons per day of pulp production. And final fifth case study is this biogas firing in rotary lime kiln. This biogas is being generated usually with the bagasse pitch filtrate only. We have tried with this foul condensate, also has the potential to have the potential COD. It also can be used for generating this biogas, but we have to take care of the H2S content. This can be reduced by the addition of this ferric chloride, and it is a low. By doing this, we have reduced the furnace oil by 3 to 3.5 metric ton per day. Also, this organic load to the effluent also minimized. Here, this table shows the quantity of coal concentrate generation, bagasse filtrate generation, and the total contribution of biogas. Usually for treating this foul condensate, we have a steam stripping column, but we have a uniqueness in this treatment. We take it into an anaerobic digest lagoon, and then we take this biogas and fire it in lime kiln. This is the picture of anaerobic lagoon. So this is the reaction taking place in anaerobic lagoon. By doing this, we have this oil per ton of lime is about 125 kg per ton. Without any co-fuel like biogas, our oil per ton is about 148 kg per ton. So we have reduced about 20 to 25 kg per ton of oil. So this is the benchmarking of specific fuel consumption. We compared with some competitors, and SPV is about 148 kg per ton of lime production. This is 100% furnace oil. With the biogas, we were around 125 kg per ton. This reduction will this furnace oil reduction about 3 to 3.5 metric ton gives a savings of about even 7 crores. So this is whatever. By doing this, the utilization of renewable energy sources. Our mill has compared to the last 5 years, 43% of increase in the renewable energy. One by the use of firing of heavy black liquor in recovery boiler, and another one is this biogas firing in lime kiln, and using of biofuels in our boiler. Presently, we were at 70% of share of renewable energy in our. So these were the highlights from the case studies. From spiral heat exchanger, 25 tons per day steam we were saving, and from the MP steam indirect heater, this green steam generation 95 tons per day, and also this power also we were raised up to 2 megawatt, and by the process re-engineering in evaporation plant, we have increased 5% of increase in the renewable share. Digester modification, this pulp production is about 30 to 50 tons per day. Pulp production has increased, and this will also contribute for 4% increase in the renewable share. Usage of biofuel to reduce the fossil fuel consumption in CPP, 40 tons per day of coal reduction, and the biogas usage in lime kiln, which will give 3.5 tons per day of furnace oil reduction. These are some of the future projects towards this net zero emissions. We have an in situ this PCC plant. Once we make this PCC plant, the transportation, the carbon emissions from the transportation part, it will come down. So we have a PCC plant, and we are planning to increase the bioenergy and group captive solar power, and the present, doubling the present bagasse pulp production. We are about 10 to 15% of bagasse pulp production we are going to double. And the application of pinch analysis technology across the mill. This will save the energy where we were losing, will bring to energy conservation opportunities. Thank you all.